Well, good afternoon, everybody. This is Jim Hodson. We're here at the Fort Worth Aviation Museum, home to the most touchable warbirds in Texas. And we've got a special guest today. We have Ken Henson with us. Hi, Ken. Glad to have you with us here this morning.
Glad to be here.
Ken, why don't you tell us a little bit about your background, and then we're going to get into Longbow today.
Okay. Well, basically, U.S. Army, and I was an Army helicopter pilot, and ended up retiring as an 06.
Okay. What helicopters did you fly?
Oh, heavens. I flew OH-13s, OH-23s, H-21s, UH-1A, B, C, D, H model, and AH-1Gs.
Okay. So you got a little bit of time in rotors.
About 3,000 hours.
Okay. We've got Javier and Robert with us here watching today so far, so welcome, folks. Feel free to ask questions at any point in time that you like here this morning. We're going to be talking about Longbow, and we said this is the introduction to Longbow, but tell me what Longbow is today, because I think some people, when you say Longbow, they think about the helicopters.
Well, Longbow, in this particular case, was a DARPA project, Defense Advanced Research Programs, which the Defense Department basically finances the cutting edge of technologies as they're exploring things for different problems. Just as a note or a side note, DARPA at least has partial credit for the Modena COVID-19 vaccine, weather satellites, GPS, drones, stealth, personal computers, and internet.
Okay.
And that comes from their website.
Okay. But Longbow is what we're here for today. So what is Longbow?
Well, Longbow is a targeting system. Now,
okay.
Remember, we're talking about 1989, 1990s technology. Let me turn this around and I'll show you a little bit about it. So the idea was to incorporate a way of providing accurate targeting data to a strike aircraft. So imagine if you take a GPS and you locate yourself in 3 dimensions. Then in turn, you have built into the system, and it's all the way out here so that the electronics don't interfere with it, is an accurate digital compass and a very accurate digital inclinometer.
Okay.
This contains an eye-sighting device, and it gives a laser pulse.
Okay, so this isn't broadcasting a beam, a light beam at all. This is just a single pulse?
A single pulse. The whole idea was indetectability.
Okay.
It originally was for special operations, low-intensity conflict, so you could participate and not be detected.
And what information are you sending to, I'm assuming you're talking about sending to an aircraft?
Absolutely.
So what kind of information was the pulse sending?
The pulse was sending a 3-dimensional location in the form of a 9-line fact message.
Okay. But the pilot doesn't read this. It's being intercepted by a device in the airplane, correct?
By a device in the airplane. So the receiver in the airplane
that then integrates with the aiming systems.
Right.
Okay.
Right directly into the fire control computer.
Okay. So as opposed to, this was designed for what? Scouts, snipers, people like that to be out in the field, special forces, to be able to do that. Now, something you were talking about earlier is translating the systems between the Army and the Air Force. Talk about that a little bit, about the map and the grid systems.
Oh, wow. That's a major headache, or at least it was up until that time, is that there's several different problems here. The Air Force uses latitude, longitude. Now, in that case, from the prime meridian, they measure degrees left or west, and degrees right or east, and then from the equator, north and south. So you get so many degrees west, so many degrees north to locate, say, in North America. The Army uses what's called military grid reference system. So they divided the whole world up into 100,000 meter squares. Now that doesn't fit on a globe. So you have 100,000 meter squares, and between these squares, you have a triangle.
Okay.
To fill in the gap.
Okay.
So if you imagine shooting artillery across that gap or calling an airstrike across that gap.
So you've got to be, so this system was translating?
The system was translating.
It was that pulse that was being sent out was translating the Army grid system to the lat-long system that the Air Force airplanes and systems could utilize.
Absolutely, using the GPS.
Using the GPS, but now after that, there isn't any laser light that the Air Force airplane is using to release a smart weapon or a laser-guided bomb.
No.
This is simply to be able to target using the targeting system that's on the airplane.
Right. Okay.
So in the late 80s, we're starting to talk about smart weapons, but this is really talking more about dumb bombs, isn't it?
This is more talking about dumb bombs. We're talking about this precedes most of these technologies.
Okay, and then where did this system go from here? Because when you brought this in, and you were involved in this in the early development stages, right?
Absolutely.
So when you brought this in for us to take a look at, I had never seen a device like this before. Right. So what does this same work today?
What you would have to do the same type of work today is it more involves laser designators.
Okay.
Where you're talking about holding a laser beam on target and letting a seeker system locate that reflection back from that target and then having the weapons home on.
Okay, so from the standpoint of the pilot, today's systems, he just has to ensure that his system picks up the beam, and then after that, his weapon's going to ride the beam to the target.
Absolutely, and the digital communication between aircraft and ground systems has advanced to the point now that it's no longer a single pulse and sending a very limited message, that it actually keeps each other in a three-dimensional basically map system.
Well, at the time when you were working on this system, what aircraft was the Air Force using that was utilizing the system?
Well, the Air Force was just then getting into what we call the Block 50, which was the latest version at that time that was just going into production.
Of the F-16s?
Of the F-16s.
Okay, it wasn't being used in any of the other aircraft?
Absolutely not.
Okay, and why the F-16s?
Well, basically because the contract from DARPA, Defense Advanced Research Project, was to General Dynamics,
okay,
who was the manufacturer of the F-16 at that time.
Okay.
So they're obviously going to put their own spin on it.
I get that. So you worked for Lockheed for a period of time also?
Yes, correct. Well, General Dynamics F-16 production became Lockheed.
Right. So how did you get involved in the Longbow?
How to get them along? Well, basically, I was in advanced design
okay,
at General Dynamics, and they came into my office one day and said, "Oh, how would you solve this problem?"
And the problem was?
How do you get accurate targeting information into a computer on an aircraft?
Okay. So when you've got somebody on the ground who's actually looking at the target, and without the pilot trying to discern it and locate it, because this is all the deal with forward air controllers.
Absolutely.
Is designating a target on the ground in such a fashion that you can get weapons on targets. And the Vietnam War era was a wholly different system than this, because like you said, this is undetectable.
Right.
So, but now this is battery operated, correct?
Battery operated.
Okay, and why don't you describe the pieces on it a little bit more, because I know you got a flap in the back that's got a keypad in it and all kinds of things.
Okay, well basically up here is, like I said, we've got the compass and the inclinometer so that they're not interfered magnetically by the electronics.
Okay.
This is the sight in here that provides the laser beam. The computer, and remember, we're talking about 1980s technology.
Right.
So we're talking about not very smart computer. It's built here into the butt.
You got a PlayStation in there.
Yeah, basically a PlayStation. And this right here is the keypad.
Yeah, turn that so people can see that part.
Yeah, let me turn this. So the keypad is built in here.
Okay, and the keypad does what?
Well, that allows you to input information into the computer where the information is displayed here one line at a time.
Okay. Now, is that the information that's going to go to the airplane?
What's going to go to the airplane?
Okay.
Who you are, who the airplane is,
okay,
and what the target is.
So now, is there any kind of yeah, there we go.
So you would look through like this.
Okay.
You would in here, and you would go to the target. When you had it located, you'd pull the trigger.
Okay.
Check the information. Correct it as necessary.
Okay.
And then
you've got the send button, and then that would send the.
So it basically cut was a 20-minute talk on down to under 5 minutes.
Okay. Okay.
And remember, this is supposedly a special forces or other operative who's being surrounded by thousands of bad guys.
Sure.
Who doesn't want to get detected.
Okay. And how do you, as the operator of the Longbow system, know whether the data got to the airplane? Do you get some kind of a
we
send
get a radio
receive
message back?
And is that the pilot saying, I've got the data, or is he going to just...
Well, normally, guess what? They say sweet or sour.
Okay.
So sweet, that's it, we got it.
Okay, so
that's all they had to say.
So you're minimizing the radio communications also.
Oh, absolutely. Again, you're sitting on the ground, you want to minimize, instead of talking on
right.
and having radio direction find, you're
right.
sending a message that's less than 2 milliseconds.
Well, and that makes you a target if you're on the ground talking people in. Yeah. You're out in the open and all the rest of the stuff. Now, what was the range on this? How far away could the airplane be and receive the signal?
Oh, he could receive the signal at 5 kilometers or better.
Okay, so he could actually not even be in the target area yet.
Absolutely.
He could be inbound to the target or sitting on a tanker someplace.
And you'd send it to him.
And get the data, and then he can follow the data to the target area and release the weapon almost without ever even seeing the target, actually, right?
Exactly.
Okay.
Now remember, we're dealing with technologies from late 80s and early 90s.
Right.
So the technology basically outgrew, the application.
Okay.
So,
yeah. So how long was this system in effect?
Well, this was done as a DARPA project.
Okay.
So it's advanced research, so we tested it. Remember, a lot of DARPA projects are never publicized and some
sure.
are still classified.
Sure.
So this would just happen to drop out and say it's no longer classified, and since it was sitting in my attic.
Okay. So where has Longbow gone from this? Where is it today?
It basically evolved more along the lines of designation.
Okay.
Than it did along the lines of covert.
Okay.
So it started out as a covert system for low intensity special operations, low intensity conflict. So it kind of shut off there and went on to the other technologies, which involved being able to obtain it, get a sight on it, hold the designator position on there.
Okay.
And
so we're still talking about line of sight with this.
right.
And it doesn't look through anything.
No.
So you've got to have a clear view of the target for this, for it to be able to work. So
well, the next technology that came from here was displaying on a map, a digital map,
okay.
where your target designation was.
Okay.
So that if you hit a blade of grass, or if you hit a tree, or if you hit a branch that you got was short of your target, you could go in there and pick up that spot on the map and move it to the center of mass instead of the front receiving edge. So if you shot at a building, instead of hitting the side of the building,
right.
you could actually move the target on the map to the middle of the building.
But I guess the weak point in this is that you're still essentially dealing with dumb weapons on
right.
the airplane. So what you've really done is you've upped the accuracy from the standpoint that the weapon system now has better information.
Absolutely.
So when the pilot's looking in the HUD or whatever in determining when to drop the weapon, it's got accurate data. Mm-hmm. So you have your error of probability gets smaller just from that standpoint, but you're still not down to where we are today, where it's actually got GPS coordinates in the weapon, or it's riding a light beam to the target.
You're talking about circular CEPs,
yes,
circular air probability of less than 5 meters.
Well, still that's extremely accurate.
With a 2,000-pound bomb and a 5-meter accuracy, we'll take it.
It's not as good as putting it through a window in a building, but it's still getting very close to being able to designate parts. It's just the whole targeting thing has come so far, and it's interesting to me that this was being developed so long ago. Mm-hmm. Because I left the Marine Corps in 1978, so this was fully 10 years after that, and we were still just using eyeballs and maps and designating that way and giving a grid coordinate to somebody, or putting a rocket down where we knew the target was, and then eyeballing and directing people onto it. So in a period of 10 years, we went from essentially almost Stone Age, because it's not a lot different than somebody with a catapult and somebody going, well, a little bit further to the right, to something like this, which was really the initial stages of smart weapons.
Right. Oh, see, we're different from having to put a smoke rocket and say, mark target.
Yeah.
Roger, target marked. Now, 50 meters north, 5 meters west, or whatever from that point.
And there's radio communications going on all of this time, so other people, whether it be anti-aircraft or things like that, can start to find you that way. So,
or for the ground observer, they can start calling mortar fire or artillery, or just wander out there and shooting.
Yeah. Well, it comes back to to return fire right on some of this stuff. So now this was DARPA, and this was intended for the Army, I'm assuming. Mm-hmm. Did this ever go to the Marine Corps or any place else that you know of?
It would have been distributed as the result from a DARPA project.
Okay.
Nobody else ever elected to pick up on it.
Okay. And what was your involvement at Lockheed in this system?
After we transitioned from General Dynamics to Lockheed, I became involved in what's called special projects.
Okay.
So ADP.
Okay.
Otherwise, the Skunk Works.
Okay. And where were you doing that work? Here?
We're doing the work here. So there was a branch of the Skunk Works. It was here in Fort Worth, actually.
Okay. Okay. And that's probably news to a lot of people. It's kind of assumed that it's all out in Palmdale and places like that. And the only aircraft you were really working with at the time was the F-16, as opposed to the only other airplane that would have been available that was being developed here would have been the F-111.
Military aircraft.
Yeah, military aircraft.
Right.
Yeah. So that would suggest that you were using test beds on other airplanes.
There were an amazing number of strange things that were done in the middle of the night.
Oh, I'm sure.
On unusual platforms.
I'm sure. What else that we haven't talked about today would you like to talk about on this, or let people know about this system?
Well, the system itself it never went much beyond where we went here, and basically it was the technology that was available at the time. And the computing technology and the digital communications technologies evolved rapidly after this.
Where did it jump from this to what?
Oh,
to lasers and GPS?
To lasers and GPS.
Okay.
Another aircraft that we have here at the Aviation Museum that you have to come see is what's called the Y-03.
Okay.
The Y-03 was a Schweitzer glider with a geared Lycoming engine and six-bladed prop. It was a silent airplane.
Right.
It was fielded by the Army in 1970 in Vietnam.
Right.
And it had a laser seeker and a laser designator on it.
Yeah, and we've talked about that one a little bit here. And talked about that airplane was quiet. You could fly over the top of somebody at 30 feet and they wouldn't hear the airplane.
Wouldn't hear the airplane.
But that was all nighttime stuff. And this is daytime, nighttime. Mm-hmm. This device, this Longbow device.
Oh, yes. So this was daytime. Anything that you could see,
you'd have to see it. But again, you could use it at night, potentially.
You could use it at night also.
Yeah.
Put a laser, you could clip on here, you could clip a laser scope.
Okay, and I think you said, too, you could also put a telescopic sight on there if you needed it.
A telescopic sight also.
Or I suppose a daylight scope or any...
Any other acquisition device can be clipped on the rail here on the top.
But you also mentioned earlier that the idea was to take this device from the size that it is now and be able to make it as small as a briefcase or something even smaller.
Right.
So that it... this obviously looks like a weapon, even though it's not a weapon as it sits.
Well, see, the thing here is if you're sitting there trying to hold a pair of binoculars, which has a laser seeker connected to it, and you're holding it in two hands, and you're looking out at a distance of 2 kilometers, your ability to hold it on target.
Right.
With the grazing angle, it can be much as 1,000 meters off, and the grazing angle of near zero.
Okay.
So the idea here was, with a bipod, this was the most accurate system where you could hold it steady.
Yeah, it could be pretty stable.
Pretty stable.
Yeah. And those legs fold up.
And the legs fold
up. So for transportability and that kind of thing. So let's see, we're getting down to our 20 minutes here. I know we've got several people online today. Does anybody have any questions for Ken? And you don't have to reserve them to Longbow. Ken has got a lot of experience in helicopters, so if there's anything you'd like to ask about, well, we talked about Kiowas and Cobras and some other things. Be free to ask those questions. In the meantime, I'm going to remind you all that we are open on Saturdays from 9 to 2 and Sundays from 11 to 3. We have Hops and Props coming up in October, and there are currently early bird prices available for tickets. Those are going to end this coming week. So I would urge you, if you're going to plan to come to Hops and Props, we have, I believe it's 14 brewers right now. We're still looking for 2 more. So if you're looking at getting onto the early bird pricing, you're going to need to do that in the next couple of days. You can find the link to that website on our website, or you can also go to the ETIX website. That's ETIX website, and just search for Fort Worth Aviation Museum and Hops and Props. Also, this coming month in August, on the 21st, we're going to be celebrating Orville Wright's birthday for National Aviation Day. So we're going to have a number of different things out here for people to experience. Going to have some open cockpits, and going to have some games for the kids and some things that we don't usually do here. Simulators going and that type of thing. So I encourage you to check your listings for that and come out and visit. I haven't seen any questions. If any come up later on, we'll pick those up off of Facebook and answer those. And we will be taking this video and putting it up on YouTube soon. So, Ken, anything else before we sign off for the day?
Well, I tell you what, I enjoy being here. I enjoy being a docent at the Fort Worth Aviation Museum. If nothing else, being here at this museum is like working in the attic of the Smithsonian.
There you go. Okay. It's a small attic, but it's still an attic, and it's still like the Smithsonian. I appreciate that a lot. Like I said, Ken is one of our docents, so come on out and visit Ken or some of the other docents here. We've got 31 airplanes. They're not all here right now, but we've got a bunch of them. We've got a couple that are in restoration off-site. So come on out and visit us, and we will be back on next Saturday with a subject to be determined. So thanks for being with us today, and have a good weekend. Thank you. Thanks, Ken.
Yeah, thank you.